Okay, so in organic compounds, the atoms forms covalent bonds, which is the sharing of electrons through the overlapping of orbitals. There are two types of orbitals lapping. I must say, just now the video actually gives additional information of what we are going to learn next. So we have two types of overlapping. One is a head-on overlapping, and we call the bond form a sigma bond. So for example, a s orbital can actually overlap with a p orbitals, and this will be a sigma bond. Or s orbitals can overlap with a s orbitals. The bond form is also a sigma bond, or a p orbitals can overlap with a p orbitals. Okay, look at the shape now. The p orbitals, only one side of the orbitals will overlap with the other side of the p orbitals, and that is called the sigma bond. And there's another type of bond, okay, which just now the video also showed is the pi bond. Okay, this is not the mathematics pi, but the symbol is the same, pi. Okay, this pi bond is a p orbital sideway overlap. Okay, if you can look at here, the p orbitals is like vertical, whereas in the sigma bond, the p orbitals is like horizontal. So the pi bond is a sideway overlap of your p orbitals. So there are two types of orbitals overlapping. If it's a head-on overlap, okay, for example, in this case, you have a head-on overlap between these orange sp2 orbitals, okay, this will form a sigma bond. Okay, and when they overlap, there will be a sharing of electrons. So you have two electrons in these overlapping orbitals. Okay, and if it's a sideway overlap, okay, sideway overlap, you will find that it will form a pi bond. Okay, sideway overlap is a pi bond. In organic compounds, the atoms forms covalent bonds, okay, and these covalent bonds can be single, double, or triple bond. A single bond is always sigma bond. A double bond consists of a sigma and a pi bond. A triple bond consists of one sigma bond and two pi bonds. Okay, so always remember, a single bond is always a sigma bond. A double bond is a 1 sigma 1 pi. A triple bond is 1 sigma 2 pi bonds. So let us look at the sample questions. Indicate the total number of sigma and pi bonds in each molecule. So you have 1, 2, and 3 of them. How do we decide what type of hybridization atoms have? Okay, so this is the simple rule that you need to remember. When there's no pi bond or all single bonds, no pi bonds, all single bonds is sp3 hybridization. Okay, when there's one pi bond, that means when there's one double bond, is a sp2 hybridization. And when there's one triple bond or two pi bond, is a sp hybridization. Okay, remember this. So indicates the number of hybridization for each of the carbon atoms. So now, how do we illustrate the bonding of sp3 carbons using molecular modeling? For example, methane. So this black color atoms here is carbon, okay, in the molecular model, and hydrogen is represented by the red color balls. Okay, so we have all these bonds are the single bonds. So these single bonds are what we call the sigma bond. Okay, so these sigma bonds is your head-on overlap of the orbitals. So for the methane, okay, if you do not know what is methane, it's 1 carbon and 4 hydrogen, CH4, contains 4 sigma bonds and 0 pi bonds. Okay. And for ethene, okay, that means it's actually carbon with a double bond over here to another carbon. And you have a CH3 over here. Okay, the carbon here is joined to 3 hydrogen atoms. The other carbon is also joined to 3 hydrogen atoms, as there's a double bond in between them. So all these, we call this CH bond or the sigma bond. Okay, these are the sigma bond. And for your double bond, one of them is a sigma bond, which is a head-on overlap between the sp2 orbitals. And for this red color bonds over here, they are actually the pi bonds, which is a side-on overlap of the p orbitals. Okay, so I'm actually going through the answers for the previous question. So there will be, for ethene, which is our C2H6, is 5 sigma bond and 1 pi bond. Remember, your double bond consists of 1 sigma bond, 1 pi bond. And lastly, we have ethyne, which is a triple bond between your carbon atoms. Okay, so the carbon has a triple bond. Okay, and this compound is C2H2, right? Each carbon has a hydrogen bond to it. So for the bond between the carbon and the hydrogen is a sigma bond. Okay, and this is also a sigma bond from the CH bond. And then you have the sigma bond between, in the triple bond, there's 1 sigma bond. And there will be 2 pi bonds, which is a side-on overlap between the unchanged p orbitals. Okay, so in total for your ethyne, C2H2, okay, or carbon, there's a triple bond in between them. You will have 3 sigma bonds and 2 pi bonds. 3 sigma bonds and 2 pi bonds. Okay, so next we have a hybrid question. State the hybridization, the bond angle, the shape of the carbon, and the number of sigma and pi bond in methane CH4. Explain the formation of sigma and pi bond with the aid of the diagram. Okay, so if you remember, the carbon atoms can form 4 bonds. The hydrogen atoms can form 1 bond. And CH4, each of the hydrogen actually form 1 bond, and there are total 4 hydrogen atoms. And all will be single bonds. Okay, so we've looked at the CH4 here. Okay, so because they are all single bonds, what type of hybridization is this? If it's all single bonds, it's sp3 hybridization. Okay, so for carbon, sp3 hybridization will be a tetrahedral shape and the angle will be 109 or 109.5 degrees. So it consists of 4 single bonds, and all these 4 single bonds will be sigma bond. Okay, there's no pi bond. They are all head-on overlappings of the orbitals. So your carbon actually hybridized to form sp3 hybrid orbitals, and these sp3 hybrid orbitals will then form a bond or overlap with your hydrogen, okay, to form the CH4, which is tetrahedral in shape. For the drawing of the orbitals, okay, you will learn more during your practical and also your tutorial. Okay, state the hybridization, bond angle, and the shape of oxygen atom now, and the number of sigma and pi bonds in water. Explain the sigma and pi bonding in water with the aid of the diagram. Okay, so for oxygen, H2O, the oxygen form 2 bonds, okay, each with a hydrogen. And you have 2 hydrogens over here, each forming 1 bond with the oxygen. So for the oxygen here, it's all single bonds. Remember, for single bonds, it's all sp3 hybridization. Okay? And it's all sigma bond. All single bonds are sigma bonds. And the angle is 105 degree and the shape is bent. Okay, so you have sp3 hybridized orbitals, which lone pair in each of the sp3 orbitals. Okay, and the shape is actually bent, as you can see from here. And there's an overlap between the hydrogen and the sp3 orbitals of the oxygen. And you state the hybridization, the bond angle, and the shape of carbon and nitrogen atoms and the total number of sigma and pi bonds, okay, in this molecule CH3CH double bond CHNH2. Explain the formation of sigma and pi bonding in CH3CH double bond CHNH2 with the aid of the diagram. Okay, so we need to state the hybridization. Let us draw the diagram first. Okay, from the left formula is a condensed formula. Okay, for the condensed formula, we can expand it out. By expanding out, that means we are writing all the bonds out. So you have CH3, just go in order, CH3. So the C must be bond to 3 hydrogen. And this C is bond to another carbon. Okay, so another carbon. And this carbon is bond to another carbon, double bond. And each of these carbon is linked to a hydrogen. Okay, so it's linked to a hydrogen, linked to a hydrogen. And this carbon is also linked to a nitrogen, which is linked to 2 hydrogens. Okay, so we call this the expanded formula. And this, we call it the condensed formula. So now let us look at each of the atom individually. So let us look at this carbon first. This carbon consists of 4 single bonds. Remember 4 single bonds, what type of hybridization? Yes, it's a sp3 hybridization. And because it's 4 single bonds in a carbon, the shape is tetrahedral and the angle is 109 degrees or 109.5 degrees. Next, we look at this carbon over here. This carbon has 2 single bonds and 1 double bond with the carbon. So what types of hybridization is this? Remember, if you have 1 double bond, you will have the hybridization is sp2. So it's a sp2 hybridization. What sort of shape is this? This is a trigonal planar shape. Okay, and the angle is 120 for trigonal planar. And this, the other carbon, same, is there's a double bond and 2 single bonds. So it's a sp2 hybridization. The shape is trigonal planar and the angle is 120. And next we have a nitrogen over here. If we look at the nitrogen, it is forming 3 single bonds. 1 single bond with carbon, 1 single bond with your hydrogen, and another single bond with hydrogen. As we can see from here, it's all single bonds. There's no double bond. So what kind of hybridization is this? So it's the sp3 hybridization. For nitrogen, the shape will be pyramidal and angle is 107 degrees. So how many sigma bonds and how many pi bonds are there in total? So we can count. Every single bond is a sigma bond. 1, 2, 3, 4. So we have 4 here, 5 sigma, okay? And your double bond is 1 sigma, 1 pi. Okay, so you have 6, 7, 8, 9, 10. So you have 10 sigma bonds. And for every double bond, you have 1 pi bond. There's only 1 double bond here, so there's 1 pi bond. So in total, we have 10 sigma bond and 1 pi bond. Okay, explain the formation of sigma and pi bonds in this compound with the aid of the diagram. So we know for this diagram what are the hybridization, and we can actually draw the hybridized orbitals in the diagram as shown. Okay, so for carbon, we'll draw a sp3 hybridized orbitals. Okay, and there's an overlap with the hydrogen 1s orbitals. And for the other carbon is a sp2 hybridization, and one of the p orbitals is unhybridized. One of the p orbitals is unhybridized, and these p orbitals, they will form a pi bond. And for nitrogen, no double bond, is all single bond, so it's sp3 hybridization. Okay, and there will be an overlap of sigma bond with the hydrogen 1s orbitals. Okay, so for this diagram, for those who are wondering how am I to draw this on paper, we'll go through during your practical session. Okay, your practical tutors will go through how to draw this diagram on pen and paper. Okay, but right now you just need to understand for sp3 orbitals. Okay, you are like drawing 4 balloon kind of shape, right? in a tetrahedral shape. And for sp2, we have to draw it trigonal planar. Okay, I shall explain more when I see you face to face during the tutorial. And we have another question. State the hybridization, the bond angle and shape of the carbon atoms and the total number of sigma and pi bond with ethyne, CH triple bond CH. Explain the formation of sigma and pi bonding in ethyne with 8 of the diagram. State the hybridization, the bond angle, the shape of the carbon atoms and the total number of sigma and pi bond in CH triple bond CH. Okay, so for C triple bond C and H, okay, if we look at the carbon here, it has a single bond with hydrogen and a triple bond with a carbon. Do you remember for triple bond, what kind of hybridization is that? Okay, for triple bond is a sp hybridization, where you have 1 sigma and 2 pi bonds for your triple bond. Okay, so there's 1 sigma and 2 pi bonds for the triple bond, and you have a single bond over here. So in total, there are 3 sigma bonds and 2 pi bonds for the ethyne, or CH triple bond CH. Okay. Explain the formation of the sigma and pi bond is ethyne with an 8 of an orbital diagram. Okay, with an 8 of the diagram. So we know that it's sp hybridization. In sp hybridization, the angle is 180 degrees Celsius. Okay, so the sp orbitals, we need to draw them linear, sp orbitals. Okay, these are the sp orbitals. And there's 2p orbitals that are not hybridized. For these 2p orbitals, we try to draw them, okay, in the y-axis and the z-axis, and there will be a pi bond. Okay, so you will have a pi bond. These p orbitals will form a, these p z orbitals will form a pi orbitals with these p z orbitals. These py orbitals will form a pi bond with these py orbitals. Okay, as of now, okay, do not worry about how to draw this on pen and paper. We'll go through during the face-to-face lesson. Okay, so now, right, we need to know in summary. Okay, we have been like, this lecture, I know, is a lot of information, a lot of things to digest. For people who are unsure, please go back and watch the lessons again, the videos again, replay. Okay, if you need any help, right, don't hesitate to contact Professor Lin. Okay, I'm here for you. And also, if my explanation is not good, I recommend you to go to watch other videos on YouTube. Okay, and a website I will recommend will be a Chem Guide. I find that it's very good in explaining, but you will also need to read on your own for Chem Guide. So in summary, right, we have learned carbon atoms is able to form 4 bonds. So what are the different types of bonds? Okay, for 4 bonds, right? For 4 bonds, you can actually form 4 single bonds. Okay, for 4 single bonds, it will be all sigma bonds, no pi bond. And then you have 1 double bond and 2 single bonds. Okay, so for 1 double bond and 2 single bonds is in total that it will be 3 sigma and 1 pi bond. For 2 double bonds, okay, 2 double bonds is 2 sigma, 2 pi. 1 triple and 1 single bond, it will be 2 sigma and 2 pi as well. So for the hybridization, okay, if it's a sp3 hybridization, that means 1 s orbitals mixed with 3 p orbitals to give us 4 sp3 orbitals, and the shape will be a tetrahedral shape. The angle will be 109 degrees. Okay, in some textbooks or websites, you find that the bond angle is 105 degrees. Okay, both are accepted. And if it's a single bond and if it's 2 single bonds and 1 double bond, remember 1 double bond is a sp2 hybridization. So that means 1 s orbitals mixed with 2 p orbitals to give us 3 sp2 orbitals plus 1 p orbitals. The shape is trigonal planar. Okay, and bond angle is 120. Example is ethene, okay, which has a double bond in between the carbon. Okay, and next we have two double bonds. For the two double bonds, okay, for the two double bonds, or your one triple, one single bonds, okay, that means it's a sp hybridization. Sp hybridization means one s orbital mixed with one p orbitals, okay, to give us two sp orbitals. To give us two sp orbitals, okay, that's a linear. The bond angle is 180 for your ethyne, 180, okay, and that's for your carbon. Okay, I apologize that Professor Lin is not very good in IT. Okay, I'm still sometimes I press the mouse pad wrongly and then it goes to the next slide as shown. Okay, sorry for that distraction. Yeah, but never mind, we'll go through as usual. Okay, for nitrogen, it is able to form three bonds. Okay, so three bonds means you can form three single bonds, or you can form one double and one single, or you can form one triple bond. They are all equals to three bonds. So for all single bonds, is all sigma bonds. Okay, so if there's a double bond, that means 2 sigma 1 pi. If it's a triple bond, it's 1 sigma 2 pi. Okay, sp3 hybridization. sp3 hybridization means 1s and 3p orbitals mixed together to give us 4 sp3 orbitals. The shape is pyramidal. The angle is 107. Okay, example is your ammonia. For sp2 hybridization, or when there's a double bond, is sp2 hybridization. You have 3 sp2 orbitals and 1 p orbitals that remain unhybridized. Okay, so the shape is bent for your nitrogen, and the angle is 120. Okay, so for the nitrogen triple bond, you have 1s and 1p orbitals, giving us 2 sp orbitals. Okay, there's no shape or bond angle you need to remember. Okay, so for oxygen, you can have all single bonds for the two bonds, and if it's all single bonds, it's a sp3 hybridization, which means 1s orbitals mixed with 3p orbitals to give us 4 sp3 orbitals. Okay, the shape is bent and the angle is 105 degrees. And for the double bond in oxygen, you have 1 sigma 1 pi. Okay, and for a double bond is a sp2 orbitals. That means you have 1s orbitals and 2p orbitals mixed together to give us 3 sp2 orbitals. Okay, and the shape is there's no need to memorize the shape and the bond angle. Okay, for the oxygen double bond. Okay, so this is an example of formaldehyde. Okay, where you have the lone pairs in the oxygen, and then you have the double bond with a carbon. Okay, and well, we have finished our very first lecture in organic chemistry. Okay, and I would like to go through the important points. Okay, so what is organic chemistry? Okay, it's mainly the chemistry of compounds that contains carbon in living organisms. Okay, so the major atoms in organic chemistry is carbon. Okay, but we commonly also can find hydrogen, oxygen, and nitrogen. And today we learn about how the orbitals actually mix together to form the different hybrid orbitals, so that we are able to explain the shape that we see in organic compounds. Okay, so important things is to remember there are three types of hybridization. You have sp3 hybridization, sp2 hybridization, and sp hybridization. For sp3 hybridization is the hybridization where you have all single bonds. Okay, as long as you have all single bonds, is sp3 hybridization. When you have a double bond, is a sp2 hybridization. When you have a triple bond, it's a sp hybridization. Okay, or you have a two double bond, that's also sp hybridization. So you just need to remember the hybridization, and we also learn the types of bonds. We learn about a sigma bond and a pi bond. For single bonds, it's all sigma bond, and then for double bond is 1 pi 1 sigma bond. And for triple bond is 1 sigma and 2 pi bonds. Okay, with that, I'll see you in the next lesson.